So, good afternoon, one and all, and welcome back to the laboratory session on our CIM. So, we were dealing with some of the turning operations related to part programming using CNC turn package in last previous class. So, today we'll be starting up with the program 5. Okay. So, I hope before starting, may I know the status of your record submission? How many of you have completed it? Introduction part, including the part programs which were done until now. I could not see any uploaded documents. What is the reason? Kindly respond if you have any problem in writing whatsoever. It was intimated to you long before. I told Tuesday is the due date. Today is already Thursday. What is the reason for not writing? Gautam Krishna? Beldar Mohammed?
Mom will submit mom next week.
Next week?
Mom, by next class we'll submit with this thing
The
also.
records weren't
Problem
available
file.
at our place.
Yeah, we told whichever type of record is available at your place, kindly do it in that only. Okay.
Ma'am, there was no record,
No
ma'am.
record.
It came yesterday, ma'am. I got it yesterday. Next class will submit, ma'am.
Yes, ma'am.
Yeah, but at least respond and let me know like what's the problem exactly, or else how we'll come to know whether you just keep mum without informing and without submitting. We won't come to know exactly what's the problem or the reality is, right? So everyone see that before Thursday, next Thursday, your entire lab record should be updated, including today's program. See that you won't give any reason in the next session.
Okay, ma'am.
Yeah, the marks will be degraded later on, right? So please submit on time before Thursday. So with that, let us start up with our regular class. I hope the slides are visible.
Yes, ma'am.
Yeah. So today we are dealing with program 5, where you'll be writing a manual part program for the given part to be done. So you are aware until now related to linear interpolation, circular interpolation, related to the turning operation and finishing. Apart from that, what is the extra operation where you can find out in the figure? Can anyone let me know which are the extra operations which are visible in the sketch? What is this part and this part? What do you mean by this? You have done this using lathe machine, right? Lathe operation, all type of operations you have done. So what does this indicate? Anyone in the class, please? You should respond. You cannot be idle like this. So in this part program, apart from turning operation, right? So we have done the grooving operation already in the previous problem, right? So that was radial grooving. So along with radial grooving here, you will be having the axial grooving and the thread cutting. So it is an external thread cutting what we'll be doing. So basically you have normal rough turning operation, smooth finishing operation, right? The groove cutting as well as the thread cutting. So accordingly, you have to select all these tools before you start up the simulation in CNC turn software. So before going to all those, let us first dig on to our write actual program, what you have to write down manually. So the required length of the blank is 110 mm and the maximum outermost diameter of the last blank here is of 45 mm. So the minor diameter for the thread cutting is given as 15 and the pitch value for the thread cutting is given as 1.5, right? And you have to do an axial groove cutting operation. For that, the depth of cut is given in 8 mm. All the values here are in terms of mm, but when you put on into the program related to this, you have to convert it into microns. So we'll go that one by one. So initially, you know to start up the program. So you will write a percentage character to indicate the program is now starting. And then you give the number for the program, right? First letter will be always O. Then you assign, we usually assign the number which is given to the part program. If it is a program number 5, we'll write it here as 05 and 05. And then you'll start the sequence right from N05. And you know that we need to select the metric system. So you select G21, right? So then you should set the tool to the home position. Here X0, Z0 indicates that it is nearly to the coordinate system. X0, Z0 means it will be exactly at this position. If you write U0, right, so then it goes to the home position. Even that is been shown here, U0 and W0. Initially, if you write G28, U0, W0, it will keep the tool to the home position away from the blank. But if you keep as X0 and Z0, it comes exactly at your reference coordinate system. So this is the difference. And then before starting, I have told you already, you have to select the tool. So first we do it up with the turning operation. So we have to do the turning operation. For that, you need to select the tool. So tool number 1, offset number 1, right? Once the tool 1 is selected for rough turning operation, you should see that the spindle is on. So you'll write M03 and you provide the spindle speed as 2000. And don't forget coolant on. So that is done. Then you have to go for rapid travels and bring the tool nearer to the blank where you need to do the operation. So now the uppermost diameter of the blank is 45. Here the tool is set somewhere here so that X will be equal to, here it is given as 51 and Z will be 1. So it will be somewhere at the top, X 51. This is 45, so it will be little more above. So X51 and Z1. Z is not 0. So you should show 1 mm here towards your right, right? So it will be somewhere here. Through the rapid travels, you will bring the tool nearer to the blank. And here, due to this updated software, we are showing the facing turning operation with feet per minute. So we start up with G94. Initially, you will provide the value of X as 1 and Z as 1 with the feed value of 0.2 per minute. But you cannot start up the program keeping the value of Z equal to 1. You should make it as 0. So in the next step, you will write it as the same thing. Everything is same. The Z becomes 0 over here. So now you have done, due to that, you will be having a facing operation here done. And as a result, the feed per minute you will be giving for every sequence of the operation which will be started. Then you know that we have to start up with the rough turning operation. So rough turning cycle is represented by G71, right? And the depth of material removal is 0.5 and the retract amount is of 1 mm. So this has to be followed with the sequence of the cycle of rough turning operation. So you know this already, we have used several times. So you will write G71 and the sequence from which the rough turning is been starting. It is from P50. So you will write it as N50 is nothing but here P50. And the last block where it ends is N75. So we'll write here as Q75. So once that is done, you have to give the allowance along the x-axis as well as the z-axis. So we'll give the allowance and the feed rate, right? So once this is done, we'll start up with our coordinate system. So first you have to see, from here to here, you have an thread cutting operation. But initially in the beginning, we won't start up with a thread cutting operation. First, we will do a linear interpolation. So if you exclude the thread cutting, the maximum diameter of the blank will be here 15. So you will keep x is equal to 15. The diameter until here is 15 only, right? This operation also, the depth of cut of removal of the groove along the radial direction also will be done later. First, you will see that you will get a blank of 15 mm with the lateral shift in the z-axis until 30 plus 10 plus 20. So this entire region could be swiped out in a single stretch. So you will write x is equal to 15, okay? And then z is equal to, this. So the linear interpolation, before going to the actual value, you set the value of x and z. So this you have to set. So first one is you are going into linear interpolation. You need x is equal to 15. So you'll provide x is equal to 15 and the value of z will be 0 because we cannot start directly giving value for the z. So first step, you have to always write with z is equal to 0. With respect to z0, what is the value of x coordinate? It will be equal to the diameter of the blank. So until here it is 15. If you exclude the thread cutting and grooving operation, the entire length here will be 15. So x you will be writing as 15 and z will be 0 and feed you will be giving as 0.3. So from then you have to see whether you have a linear interpolation or circular. So next you need to traverse in a linear interpolation only until here, right? So until here also the value of x is 15. So you guys will write x is equal to 15. So until here, what is the value of z? So it is 30 plus 10 plus 20. So again it is 60. Since it is in opposite direction, it is minus 60. So you will write x is equal to 15 and z is equal to minus 60. Again, since it is G94, you have to provide the feed per every minute. So you write again f is equal to what is the feed rate required, and we will write here as 0.3. That is done. So now our tool is at here with x is equal to 15 and z is equal to minus 60, right? So later, you cannot go with linear interpolation. You need a circular interpolation. How it is moving? It is moving in a clockwise direction. So for clockwise, which is the code you have to use, it is G02. So you will write it as G02. What about the coordinate for x? It is, you have to take the diameter of the blank here. So the next step, diameter of the blank is nothing but 25. So x value will be 25. You will write the circular interpolation in clockwise direction. Coordinate for x as 25, right? And what about the z? Previously, the z was here 60. Now it has traversed 5 distance. Okay, so here, whether the radius is here 5 mm and even the length will be 5. So it was minus 60 and minus 5, it becomes minus 65. So you will write z minus 65. And for the circular interpolation, what is the radius? The value also you have to give, that is R5. So you will type it as R5 and give the feed rate again as 0.2. So now the tool is here. So once the tool has reached here, next we have to see whether it has linear or circular interpolation. Since it is circular interpolation, since it is linear interpolation, you will write it as G01 and x value remains the same until here. So x is 25, but z value changes. Before z was here at minus 65. So minus 65 and minus 15, again you add on, then you will get the value of z as minus 80. So again, you write the feed rate as 0.3. So in this case, now we have reached until this point. So after the tool is here, again, you have to see whether you have a linear or in circular interpolation. But you have a circular interpolation here, right? It is moving in anti-clockwise direction. So you have to write it as G03, right? G03, and the value of x will be 45. What about the value of z? You have to add on 10 more extra. So it was 80, minus 80 and minus 10. It becomes minus 90, right? And you have to give the diameter for the circular, radius for the circular interpolation. Here the radius is given as 10. So you will write the value of R is equal to 10. Then the feed value will be again 0.2. So with this, now we are at this end. Circular interpolation is done and some last part of the blank is left out. So you have to see now again whether it is a linear or circular. Obviously, it is a linear interpolation. It has to reach until here. So what is the value for x? It will be the diameter of this blank. So diameter of the blank will be nothing but x is equal to 45 mm, right? But now z has to traverse still 20 more. So it was minus 80 or minus 90 before? It was minus 90. right? So minus 90 and again minus 20 will add on so that the tool will come until here. So it becomes minus 110 for the value of Z. So you will write X will be the same 45, Z is minus 110, and you will give the feed value as 0.2. So now the tool has reached at this position and the rough turning cycle has been completed. Once this is done, you need to change the tool. So to make the tool change, you need to make the spindle off. So you will write it as M05. Along with the spindle off, don't forget to make the coolant off. So you will make the coolant also off. After this, you have to send the tool to its home position and not to the coordinate at x is equal to 0 and y is equal to 0. Since you have to send the tool to home position, you will write as u0 and w0. Once the tool is in tool position, home position, then you will change the tool. So to change the tool again, you have to write M06 and now you have to select the tool number 2 for finishing turning operation, and hence you will write T02 offset number 2. So once the tool has been set, you have to again make the spindle on. For that you have to write as M03 and give the spindle speed as 3000, right? So after that, you should not forget to make the coolant on. So you will on the coolant. Once this is done, then you have to start up with the finish turning operation cycle, finishing operation cycle, turning operation cycle. So you know that turning operation for finishing is represented by G70. So you type G70. Again, the block right from the sequence of N50 to N75 has to be run for finishing operation. So the same values here you will write as P50 and Q75. But you have to see that the feed rate what you assign for smooth finishing should be very less. So you please change the feed rate to the negligible and the least value. Here we have shown it as 0.02. After this, now you have to make the tool to go to the home position, right? So then you will, yeah, I didn't tell you. So once this is written, the entire sequence of operation for the finishing cycle, right from 70 to, right from P50 to Q75 means N50 to N75 will be completed and smooth finishing of turning will be done. So once the turning operation of smooth finish is done, then again the tool has to be sent to the home position. Why? Because you need to change the tool. Because you need the other operation to be done, the groove cutting in radial axis, the groove cutting in axial direction, and also the thread cutting, right? So these operations are still pending. So you will set right the tool to the home position by writing G28, U0 and W0. Once that is done, what you have to do, you have to make the spindle off. So please make the spindle off, coolant off, and change the tool. To change the tool, you have to write again M06 and select the third tool. Okay, so after selecting the tool, again you have to make the spindle on. So be careful in setting the speed for the operations. Based on the operation you're performing, the spindle speed has to be reduced. So once the spindle speed you have assigned, you will then make the coolant on. Okay, so after this, now the actual process has to be carried out. So we are going with G75. Can anyone tell me what is G75? We have done this already before. I explained you G75 and G74 also. What do you mean by G75? Anyone in the class, please? You have to answer, guys. Hello, you people are there? What is G75? Grooving. In which direction? To answer the attendance, your mic will be proper. To answer the question, only you will send the message in the chat. That is not the way. You should respond. So G75, we usually do the peg drilling along the x-axis. Okay, so where we will do the required groove cutting operation along the x direction, right? So if we need along the radial axis, so then we will use the other code as G74. So now we are looking up for G75. What is the syntax for G75? Right? So G75 mainly is our groove cutting, this one with respect to the radial of the radial axis. So if you need the groove cutting with respect to the radial axis of the specimen, then you will use G75. If you need in the axial direction, then that is G74. So you have to see in the diagram where the grooving operation has to be done. It is done along the axial, along the radial direction, which is parallel to our x-axis, right? So we have to use G75. So what is the syntax usually used for G75? So G75 comes with G75R. So where R will show you the retract amount which has to be done for each peg, right? So that you will write what is the amount to be retracted in place of R. Then you have to show the value for X, which is X coordinate, and the Z coordinate where the groove has to end. So once you assign the value of X and Z, you have to provide the value of depth of peg what you need per each step. Okay. So then that is a value what you will give for the peg depth. But be sure you have to keep the value of peg depth in microns, not in mm. So if the depth of peg is given in mm, you have to convert that into microns. And you need a lateral shift along the z-axis from where to where you need the groove cutting operation. So the lateral shift in the z-axis will be nothing but your value of Q. And finally, you have to give the feed rate. What is the feed rate which is assigned to make the groove cutting operation being done completely? Okay, so this is the syntax what we usually follow. So as per that, before starting with G75, first you have to use the rapid traverse and bring the tool nearer to the place where the groove cutting operation has to be done. So here the value of X is assigned as 16. Okay, so where we need exactly the groove cutting operation is from this position to this, right, in the radial direction. So the uppermost diameter here will be 15. So you're bringing the tool nearer to that diameter. So instead of giving 15 directly, it touches the tool. It has been assigned as X is equal to 16. So it will be 1 mm slightly above the position where you need the radial groove cutting operation, right? And similarly, you have to provide the value for Z. So you need to start the groove cutting operation from here and you have to end until here. So the value of Z should be exactly 30. If you give 30, the value of Z will be here and X is 16. So it will be somewhere here. This is totally 15 mm. You will keep the tool such that it is 1 mm above that 15 mm diameter and it is exactly on Z is equal to minus 30. So by using rapid traverse, you will set the tool right near the place where the groove cutting has to be done. So once you assign the tool exactly to the position where you need to do groove cutting, then you come for the grooving cycle. So G75 is our command of G code for grooving cycle in radial axis, right? So you will write G75 and the amount of the material to be retracted is given here as 2. So after that, the full part of the syntax has to be completed. So I told you the syntax, what does each parameter stand for? Same thing has been assigned over here now, right? Again, you will write G75. The value of X is 10, right? So you need exactly here the groove cutting at X is equal to 10. So you will write X is equal to 10. And similarly, Z. So from where to where you need the groove cutting? From here to here. So now X is at, so now Z is at 30. It has to reach until 40, right? So z is minus 30. Now you will assign z to be as minus 40. So you will write z as minus 40. Value of x is equal to 10. And P is the peck depth, what you have to give. If it is 0.1 mm, you have to convert that into microns, so it becomes 1000 microns. And then what does the syntax tell for Q? So Q is the lateral shift about in the z-axis. So until where you need, it is in mm, the z-axis value. So you have to go back to the diagram and see. Just a second. Yeah, Q is the lateral shift about in the z-axis. So that Q value here is been given in the example, it has been given as 1500. And similarly, in our problem, the value of Q will be as 800 microns. And here for the axial groove cutting, there won't be any radius required, but you have to assign the value of R is equal to 0 by default, or else it shows the syntax error. So you will just show value of R is equal to 0 and you assign the feed rate. Once you assign the feed rate, the grooving cycle is being completed. So it starts grooving as per the required dimension, and this grooving part will be completed. So once this grooving part is completed, again what we have to do is we have to make the spindle off and the coolant off. Once this is off, we have to send the tool again to its home position. So you will write G28, you will write U0 and W0, which will send the tool to its home position away from the blank. So after that, again, you need to change the tool. Why? Because the axial groove cutting and the thread cutting is still pending, right? So now you will select the tool you have as tool 4. For that, you have to write M06 and assign tool number 4, offset number 4. Once the tool has been set, make the spindle on, assign the value for the spindle, right, and make the coolant on. So once this is done, again you have to use rapid traverse and bring the tool nearer to the blank where the operation has to be done. Here we are going with G76. G76 is nothing but the code what we use for thread cutting, external thread cutting operation. So from where to where the thread cutting has to be done? From this end where x is equal to 15 and it has to move this entire distance and thread cutting has to be done. So in this problem, the minor diameter is given as 15 and the pitch is been given as 1.5. So this you have to be very clear enough, right? So you have to use the same specification which has been given in the sketch. Don't blindly use some other value of pitch and some other internal diameter value. Please stick on to the values given in the sketch. Okay. So now for that, you should be knowing the syntax of thread cutting. So before going, again, it's our duty to keep the tool nearer to the workpiece. So now we need the thread cutting from this end to this end. So for that, the tool should be exactly at 15 mm, the diameter for the blank here. But you will not keep it exactly. You can increase 1 mm extra, or you can assign x is equal to 15, but you will not make z is equal to 0. You will keep little bit away. Okay, so you will assign as z is equal to 1. Right, so z will be equal to 1 and x will be equal to 15. So it is very near to the blank where the thread cutting has to be started, but it is not touching. If you give z is equal to 0, then the tool will touch across the corner of your blank. Since you have assigned z is equal to 1, it is little bit away from the blank and the tool is set to do with the operation. So once the proper tool has been assigned for the proper operation, then you have to go up with the process. So this is now related to thread cutting. So you should know the syntax of thread cutting. What is the syntax for thread cutting operation? G76. This was discussed earlier. Yeah, I had written here somewhere. Okay, let me see. Yeah, written at the end, right? So thread cycling, thread cutting cycle is represented by the code G76, right? So it will be having the thread depth, what is the depth of the first cut and how it could be cut, right? With respect to the depth of cut, you assign that much amount of calculations you can find out for equal part of the area with respect to the tool tip. So that is okay. We will be focusing mainly on the syntax here. So G76 has a syntax in this way. So G76, after that you will be writing the letter P. Okay. So P into in the bracket M, R and A. So this entire combination will assign you the value of P. And later you have the word terminology Q, okay, and then you have the terminology R. So what does each stands for? So in P you have three terms. One is M, R and A. So what is M? It is nothing but the number of idle passes after each cut. Okay, so suppose if the number of idle passes you need as 2 after each thread cut, you have to give 2 idle passes. So then it will just have an idle pass twice before starting the next cut, right? So number of idle pass you need, you will assign it as the number what you need. And chamfer distance at the end. Suppose you need a chamfer, you will be having a thread cutting like this. If you need a chamfer somewhere and then the thread cutting, then you have to assign some value for chamfer effect. If you don't want chamfering, then you'll give the value of chamfer as 0. Okay. So if you need the value of chamfer distance, then you have to assign the value for R. If you don't want the chamfer distance before the thread cutting, after the thread cutting, then you have to provide the value as 0. So if you don't want, you will put directly 0. Okay. And then A. So A is the angle of the tool tip. So what is the thread angle you need for the thread cutting operation? Usually it will be 60 degree. Sometimes it could be 55 in the rare cases. But the thread angle always what we use and prefer is 60 degree. So please write it as 60 degree. If you don't write degree, it won't be able to understood that it is degree. Okay, so please write it as value of A as the tool angle. Sorry, the thread angle. So this is the combination of the values what you assign for the term P, right? So next you have to give the value for Q. So what is Q? Q will provide the minimum depth of cut in terms of micron. If the depth of cut is assigned as 0.1 mm, you have to convert that into microns. Then it becomes 100 microns. So in place of Q, you have to write the depth of cut in terms of microns only, not in mm. After this, you have to write the value for R. So what is R? You are providing and finishing allowance in terms of microns. Okay, so finishing allowance so that there will be no scrap and hook or any amount of wastages. With the help of finishing allowance, a neatly maintained thread cutting could be achieved at the external surface. So allowance, if it is given as 0.15, usually we give the allowance along the Z axis, right? So similarly for thread cutting also, you will assign some finishing allowance. It is in terms of mm, but you will later convert it into microns. So this is the part of P, Q and R what you have to assign. So you have one more line of syntax which is related to our coordinates also. So here you will assign the coordinates of the endpoint from where to where you need the thread cutting. Okay, so this will be represented by X and Z. And here you have R. Okay, so R of I will always provide the taper value what you need for thread cutting. Okay, so this taper value will be positive if you're doing an external thread cutting operation. And if you're doing an internal thread cutting operation, the taper value will be considered to be as negative. And if you need a straight thread, obviously you will consider this as to be equal to 0. Okay, so this is the value of R, what it stands for. Next, P of K is nothing but the thread depth, what you need in the thread cutting operation. So this is basically the radial value, what you give in terms of micron. If the thread depth is of 1.2 mm, you have to assign that as 1200, okay, microns. And next you have Q, which is the depth of cut, which will be provided in terms of radial value in terms of microns. If the depth of cut assigned is 0.4, then it will be 400 mm. If you're giving us 0.6 mm, then it will be 600 mm. And finally, the lead of the thread, right? So F will provide you the pitch thread value. So that value you will assign here how much it is. So this is a format what one has to follow to give the values for performing an external thread cutting operation for the given blank. Okay, so same thing now. We will go back to the problem number 5. Right. So we were here. This tool was set nearer to the blank where thread cutting was supposed to be started. So next you will start up with G76. So you write G76 and the value of P stands with 3 values. I told you the number of idle passes you need, right? Okay, this is problem for number 5 only. Yeah, the number of idle passes you need. If you need any chamfering, please give the value of chamfering. And then last 2 digit is nothing but the thread angle. Okay, so thread angle we need it as 60 degree. So it is 303 is for number of idle passes, 15 is the chamfering value, and 60 will be your thread angle. So once this is done, then you have to assign the value of Q. So Q, I told you, that is the depth of cut which has to be removed. If it is 0.5 mm, you will change that into 0.5 into microns, it becomes 500 microns. And for the thread cutting, no need to provide the value of R. But still, we have to put the value of R is equal to 0 to see that you won't get any error in the syntax. So once that is done, again assign the feed rate, the value of F is equal to 0.01. So one part is over. Apart from that, you have to provide the coordinates, what is X and Z exactly, right? So you have to calculate the value of X and Z. For that, you need to do the calculation. Thread cutting calculation, you have done this already using lathe operations also in your previous semesters. So you have to see what is the minor diameter and the pitch thread is been given. So thread height, we know the formula is equal to, thread height is nothing but P, which is equal to 0.613 into pitch of the thread. So the pitch of the thread assigned here is 1.5. So you will multiply 0.613 into 1.5. It will provide you the value in terms of mm. Please don't forget to convert that into microns. The syntax, the program will understand the unit in microns, not in mm. Kindly convert that into microns and see how much it is. Okay. So then you can, yeah, before going, we need to calculate the minor diameter. So minor diameter X is equal to 15 minus twice the thread height. So thread height we calculated as 919.5 microns. But here, while substituting, write it in terms of mm only. Okay. So 15 minus 2 into 0.9195 mm. Right. So it will yield you 13.161. So go back here and write the value of X to be as 13.161 and Z value. So Z value, look at the diagram here, from where to where you need, right? For minus 30, right? So then from here at Z is equal to 0 to Z is equal to minus 30. So you have assigned, you need until Z is equal to minus 13. So after that, you have to assign the pitch. height of the pitch, right? The thread pitch, which is 919.5 microns. Don't write 0.5 microns, just leave it and write the whole number as 919. Don't write the point after the decimal. Just round it out to the nearest number. So it's always better if it is 919.5, leave 0.5 and just take the whole number. So this is done. Here also, there is no need of showing the radius value, but for the syntax to be followed, write r is equal to 0. And now the value of q, right? So the value of q is the depth of cut removal, right? So that you have to, if it is 0.4 mm, you have to convert that into microns. So it becomes 400 microns and assign the feed. So once that is done, right, the thread cutting operation will be completed from here to here in both the sides. So once the thread cutting operation, I mean the external thread cutting operation has been done, then what we can do is you have to stop the spindle. So we'll write M05, M09. So after this, what is our next work is, because the axial grooving operation is still pending, you need to change the tool again. Since you need to change the tool, you need to put the tool to its home position. So you'll write G28, U0 and W0. So once you have set the tool to the home position, what you have to do, the next step is you have to change the tool. So you will write M06 and change the tool for axial groove cutting operation. It is assigned as tool number 5, right? So you'll write T05, offset number 05. So once the tool has been set, what is our next work? You have to make the spindle on, right? So please make the spindle on, provide the spindle speed and make the coolant on. Once this is done, now you have to bring the tool back nearer to the blank using rapid traverse. So you write G00, X0, and don't write Z0. You are just assigning the values, a very small value for Z, so that the tool is almost nearer to the place where the axial groove cutting operation has to be done. You are not touching the blank. You are keeping the tool very near to the blank, so that it can start further to do the groove cutting operation. So now the tool is all set. Only thing is you have to start the operation. So which is the syntax we follow for axial groove cutting operation? It is G74, right? So you have to follow the syntax used for G74. I hope we have done with that also, right? So G74 here, G74R. So R is nothing but the retract amount at each peck, right? So you will write what is the amount to be retracted at each peck. And later again, you have to follow G74. Z, what is that? It is the coordinate of the hole, from where to where you need to do it. And Q is the peck depth. What is the depth through which the axial grooving has to be done? So in the diagram, they will give you the depth of grooving. It is 8 mm. You have to convert that into microns and assign the value, right? So that will be the peck depth in microns. And after that, you will assign the value of F is equal to what? It is the feed rate. So the same thing now we have to follow here, right? So G74, the amount of material to be retracted, we are writing 2. Then we have to follow G74 with the coordinate for X and Z. Since you are starting the groove cutting from axial direction at the coordinate system, X0, Z0, right? You will write initially X is equal to 0 and the groove cutting until where you need. So you have to shift you have to provide the lateral shift along the Z axis. So it is minus 15, right? So the depth here from where to where it's needed is 15 mm depth. So Z will be equal to 15, right? So once the value of Z is assigned, you should provide the depth of cut. So depth of cut is given as 8 mm is the depth of cut. So you will provide that as in terms of, in terms of microns, right? So 8 mm duct will be converted into microns. It becomes 800 microns. Then you will assign the feed value as 0.2. So this completes the last grooving operation along the axial direction. So all the operations now are completed. So now it is the time where you can end the program. Again, you have to make the spindle off, the coolant off. Once it is off, what we have to do is you have to again send the tool to its home position. So you will write G28, U0 and W0. So the tool is set back to its home position. After that, you will make the machine to stop and write the program end character, which is percentage again. So this completes the entire operation of all the type which is needed, right from rough turning to the smooth finishing, axial groove cutting, radial groove cutting, and thread cutting operation. So here in this program, we have done 5 type of operations, right? So you should be able to write any program once you are thorough with the concept and the syntax of all the operation, irrespective of the given sketch, you will be able to write the program on your own. Only thing is you have to understand the syntax and the concept. Hope it is clear to you all. Hello. Kindly respond. Are you people there?
Yes, ma'am.
Yeah. So now let us just start up with a video to see the simulation in the CNC turn. I'll just stop the slide and start up with a video. Just 2 seconds.
Ma'am, can we directly write in the record, ma'am, or do we have to write in observation as well?
Observation, just make a rough sketch because you were supposed to maintain observation as well as a record.
Ma'am, please, ma'am. Already we wrote so much and then later you are telling us to write record again. We have to repeat the same thing again. No, ma'am. Please, ma'am.
Yeah, see, record you have the marks, right? And when you were coming into the practicals, were you not maintaining an observation work?
Ma'am, observation we used to write only some certain stuff, ma'am. But now again, if we repeat the full thing over again, no, ma'am. That's why it's double the work. Now,
Ma'am,
whatever we've written again, we have to write in the record. From
need
today's
diagram
experiment, we'll
will
write
write.
directly in the record only, ma'am.
Diagram will do in the observation. Program part can we directly write in the record, ma'am?
Yeah, so what I suggest is you write the program number, the sketch, and the syntax related to that in your observation book, and the actual program, directly write it into your record. Okay? Is that
Okay.
fine?
Ma'am, it's almost the same thing, no, ma'am.
Just a rough sketch at least in your observation. I'm not asking you to take pencil scale, draw the line and do it, right? How much time it takes to just draw a rough sketch? See, this
Ma'am,
time
but we're doing
everything
okay.
is...
No, ma'am. We'll do rough sketch only in the observation, ma'am. But what we're saying is the other stuff and all, including the program, we'll write the record directly, ma'am.
Yeah, you can do that. I'm just asking the main thing. Suppose if you're doing this operation, how many operations you are doing? At least mention those syntax. Okay, the name of the syntax, not
Okay,
full,
ma'am.
at least the
Okay,
minimum
ma'am.
thing. I'm not asking you to
Okay.
describe what does
Okay,
each
ma'am.
parameter mean. At least the
Okay, fine,
syntax
ma'am.
of the operations, what you're doing. Okay,
Okay, ma'am. We'll do that, ma'am.
yeah. Is the screen visible for you all? Hello?
Our
Yes, ma'am.
monitor is visible, ma'am. Desktop, ma'am.
Yeah, monitor is visible, right? Yeah.
Yes, ma'am.
So now the CNC turn is on and then the existing part will be opened. And now Sir is selecting program number 5 as we have discussed. So it is there now in the program editor. You can select the entire program and check for the error initially, or you can save it before and select the blank and then check error. Anything is fine. So it's always better to save and then go for selecting the blank. So blank size you have to select as per the requirement. A little buffer if you keep, it's also no problem. But see that you are selecting the proper length and diameter as per the dimensions given in your sketch. Z value could be 1 or 2. Don't start up with 0. That's it. After the blank is set, just press OK. And then you have to select the machine. Just a second. Hello, ma'am. Ma'am, you were full busy with the practicals. I'll get free only after 3:30. Avag bartini, ma'am. I will give from morning. Yeah. हाँ 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 yes yes हाँ हाँ ಹೌದು ಖಂಡಿತ ಇಲ್ಲ ಮ್ಯಾಮ್ ಟುಡೇ ಹೋಲ್ ಡೇ ಐ ವಾಸ್ ಬಿಸಿ ಇಲ್ಲ ಅಂದ್ರೆ ನಾನು ಆಗ್ಲೇನೆ ಬರ್ತಾ ಇದ್ದೆ ಆಫ್ಟರ್ 3:30 ಐ ವಿಲ್ ಕಮ್ ವಿತ್ ದ ಲೆಟರ್ a draft one is there. I have to fine tune little bit. No. Okay. Right. ಹೌದು ರೈಟ್ ಹೌದು ಎಸ್ ಮ್ಯಾಮ್ ತಗೊಂಬರ್ತೇನೆ ಯಾ ಥ್ಯಾಂಕ್ ಯು ಬಾಯ್ ಬಾಯ್ I'm sorry, there was a call from principal office. I was supposed to receive. So first we will select it and then we will select the machine also. For the operation, please select the machine. I think that is done here. Yeah, the blank is done. And you have to select the machine as Fanuk. So then you will go for checking the error. So if any error, it shows there is an error, or else you can directly go for the selection of the tool. Here already the tool is being selected, right? So please remove all the tools and you please add on as per the requirement. So delete the existing tool in the tool library. Then you configure your own tool numbers. So you need first the rough turning operation. Select the rough turning operation, right, with the radius of 0.8. This is done for rough turning. Then you go for smooth turning operation, right? Then again you go with the nose radius of 0.2 for smooth turning operation. This is done. We usually select these two. Then we go for tool number 3. So tool number 3 will provide you for the groove cutting. So it is in metric unit. So you will select the groove cutting tool as per the depth of cut which is being needed, right? So it will be in the database. If you need any changes with respect to the depth of cut, you can change, right? So initially here, this tool is feasible to have 8 mm depth. So in our requirement is also 8 mm. So we have assigned with the same tool for groove cutting operation. Then you go for tool number 4, right? So it provides you for external thread cutting. And in external thread cutting operation, always we go with threading angle of 60, right? So we usually select the first one. So which shows the thread angle the holder length, and maximum thread depth what you can have. If you need any changes, you can make it. By default, we usually go with the first one. So all the four tools are done. And lastly, the last tool, this one you have to do it for the axial groove cutting operation, right? So here you can change the depth, the flute length, if it is more than that of the assigned, right? So here the depth required is only 8 mm, and even we have in the library for 8 mm. So we can select the things which are there in the database. If it happens that more depth of cut is needed and the assigned tool is having only a depth of 8 mm, then you can change the flute length and type the value as per the requirement. So this is how you will assign all the tools as per the operations which you are supposed to do. So once it is done, you please save it, okay, so that all the tools assigned are embedded. So then you will start simulating, you will get an blank, right? So it will be zoomed out. Just draw a box, it will get zoomed out. Okay, so then you can start doing the simulating part. Check the start stimulate. Since you take G94, it does the facing operation in the initial thing. Then it starts with a rough turning operation. Right from sequence number N50 to that of N75, the rough turning operation will be done. So you can gradually observe how the rough turning operation for all the sequence numbers are taking place. So the tool will be set to its home position. The tool gets changed, and now it's starting with that of axial groove cutting operation, right? You can observe as per the diagram what I showed you before. So as per that, the groove cutting operation, now it will be done. So where the value of x is 10 and it has to move z to minus 40. So from here it will be exactly to minus 40. So now the thread cutting operations completed, and now it is starting with the radial groove cutting operation. Sorry, the axial groove cutting operation. And once it's completed, it ends. So how the operation will be performed with respect to 5 types. One is a turning operation, smooth turning, rough turning, thread cutting, radial grooving, and axial grooving. So this is about the program number 5. So you please write down the question, take the snapshot of the sketch. You have to write this in the sketchbook. and the program. In the manual, what we have shared, there are some still minor errors. Okay, so this is the corrected version of it, what I'm showing you in the PPT. You please take down this as well. The edited manual will be shared to you all at the earliest. You can refer to my PPT slides for your reference. I can share this PPT also. Please take the question number, the sketch. Have you taken it out? Hello? Is it done? Kindly
Yes, ma'am, done,
respond.
ma'am.
Yeah. So shall I go up with the next program explanation?
Ma'am, next program, ma'am.
Yeah.
We're doing 2 programs today, ma'am.
Yeah. What? Any problem you have?
No, ma'am, it's confirming.
Okay. The simulation part I will tell you in the next class. At least I'll just brief out the program. It is similar, the same operation. Just for your understanding, we will move quickly. Initially, I went in very depth as that was new to you. So now it is almost the same thing. You can observe here also you have a groove cutting operation, right? The axial and the radial groove cutting and the thread cutting operation. Along with that, you have like a small taper turning operation and linear interpolations. And here you don't have any circular interpolations. Or else I will assign one work to you all. Currently, I have explained all the program. So this is also similar to it. You will write the program for this by yourself and you will post this for me in the Google Classroom. Okay, so you please do this until right from program number 1 to 5. I have explained each and every program. So this is not any different. This include all the operations what I have explained you until now. So kindly write a part program and upload to me by today. Okay, so then only I'll take the attendance. Please take the sketch. Then only you will realize how and when to use the syntax properly. Right? So please open your book, take down the problem number 6, take the sketch, start writing and post me. Right? I will just create as assignment for program 6. Just upload the program. Don't see anywhere. Write by yourself. And then for cross-checking, I can show you the program here. Okay? Please do this work. That will help you to have a better understanding. I will keep this slide open. Right? Look to the sketch. Start writing the program. The thread calculation, if you need the values, I'll show here. The same calculation what we did for the previous one. Take down the sketch. I will create a post here in the assignment in the Google Classroom. Let me see who will post me the first. Be quick. I'll just assign in the Google Classroom. Please don't copy. Use your own mind, quotes, and write it down. You will really feel happy when you have done at least once without seeing. If you do once, right, you can write any program by yourself. So it includes all the operations. Try to write it down. I will just create an Google Classroom for it. Assignment for it. Did you people started writing? I've assigned the time as 4:30. See that before 4:30 you do submit this. You will learn the things. It will be helpful for you only. Kindly don't take it for granted. Okay, it has been posted as assignment number 4. In the bracket, it is written as program 6. So please upload for the same assignment. Write it in a plain sheet of paper and upload it at the earliest. Now keep doing it and answer your attendance also. Today is 15. Abdul Khalik Pasha, present. Akhil KV,
Ma'am, Abdul 001.
Abdul 001. Yeah, he's not there.
Ma'am, it's me.
Hello.
Mine is 001, ma'am. It comes first.
Yeah, Abdul Khalik Pasha, I'm telling.
Yes, ma'am. Present, ma'am.
Yeah. Akhil KV. Okay. Alok M.
Yes, ma'am.
Today is your first class, Alok. Please don't
No,
miss
ma'am, we
any
spoke the
classes.
previous, ma'am, we spoke the previous class also.
That was for the theory. Tribology.
No, ma'am, we
Lab.
spoke during the class. Yes, ma'am, during the lab we spoke.
Last lab where you present.
Yes, ma'am.
Last was your first class then. I don't remember. I spoke with you in the theory class, I guess, tribology.
No, ma'am, I
Anil
was present the
Kumar.
previous class.
Okay. Anil Kumar Vaskar. Okay. Please write the program, don't waste time. Ankesh Aman. Ankesh.
It's me, ma'am.
Ankesh Aman left. Is he there? Gautam Krishna. Gautam.
Yes, ma'am.
Yeah.
Excuse me, ma'am. Ankesh present, ma'am.
Ankesh present. Okay.
Hello, ma'am.
Yeah. Balaji VR. Okay. Basuvraj.
Yes, ma'am.
Beldar Mohammed.
Present, ma'am.
Chaitanya SR.
Present, ma'am.
Chandan KN. Okay. Chetan Kumar. Chetan. Okay. Dheeraj. Dheeraj LN. Okay. Ishant. Okay. Arshit S. Arshit. Arshit is absent. Himanka. Okay. Kanishka Reddy. Okay. Srinaga. Kolepara Srinaga. Okay. Kunal Raj Kiran. Kunal Raj Kiran. Absent. Danush. Danush. Mohammad Ayan.
Present, ma'am.
Okay. Mohammad Junaid. Okay. Sri Prasad.
Yes, ma'am. I'm here, ma'am.
Yeah. Fine. Please upload the program number 6 into the Google Classroom before 4:30. Okay, and see that by the next practical, your all programs and the introduction part should be ready in the sketch, including program number 6. And in the next session, I will show the demonstration of program number 6, and then we will start up with the program number 7. So sixth one, how you're writing, that I have to understand today. Without seeing, please write in your own way, but use proper syntax. It should be up to the mark. It includes all the operations what we have done until now. So all the programs were given from my end. So this is only the one program what you'll be writing from your end. Let me see that how well you will write it. Okay. So I need all 22, 25 students assignments on program number 6 before 4:30 today without fail. Please don't give any reasons. For record also you told many reasons. I have accepted it. I have given the time until the next week, but this assignment to be uploaded on or before 4:30 today without fail. See that you will complete it. Okay. So I'll be waiting and I will check the response. Those who write really, so that will show how much you have understood. So based on this, I can evaluate how much you know about the programming aspects, what you have studied until now. So just take, learn, understand, write, and submit me this program without fail by 4:30. So take care. Have a nice day. Bye-bye.